Hi boys and girls, today we're going to be doing lesson 5 of unit 12. It's the effects of the leading coefficient on a graph. So the do now says to graph the functions on the same graph. So I have f of x equals x squared and g of x equals 2x squared. So we know that f of x and g of x are really the same thing as a y equals. So what I'm going to do is I'm going to go in my calculator, get my table so that I can graph them. I hit y equals. I'm going to type in x squared first and just get the table for that. Remember, when I'm dealing with parabolas, because this 2 is an exponent here, it's being squared, I know I'm going to have a parabola. So I want to look for the balance in the calculator in my y values. So I found my balance in my table. I have a 9 and a 9, 4, 4, 1, 1, and then 0 in the middle. So those are the points, the coordinates that I'm going to list in my table. So I'm going to write them right here. So I had negative 3, 9. I had negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. So again, this is the balance that I was talking about. And now I need to do my other one. So I'm going to hit y equals. Clear this out. I'm going to put 2x squared. And I'm going to write the table. So this winded up being right there for me, my balance. So I'm going to start with negative 3, 18. Again, I'm just going to write my table. Oops. So I have negative 3, 18 from my calculator. I have negative 2, 8. I have negative 1, 2. I have 0, 0. I have 1, 2. I have 2, 8. And I have 3, 18. So if you look at those y values and you compare them of the two tables, I have a 9 and then I have an 18. I have a 4, an 8. I have a 1, a 2, a 0, 0, a 1, a 2, 4, 8, and 9, 18. We'll talk about this a little bit later, but this up here, this 2 means that I'm multiplying by 2. So this 9, if you multiply it by 2, you get 18, right? Because we're using all the same x values. If I multiplied 2 times 4, I would get 8. 1 times 2, I would get 2. 0 times 2, it would just stay at 0. And then back with the other values. 1 times 2 is 2, 4 times 2 is 8, 9 times 2 is 18. Okay, so I have my balance here. And now I need to graph them. So I'm going to graph the first one, f of x equals x squared. Negative 3, I go left 3, up 9. Negative 2, 4, I go left 2, up 4. Negative 1, 1, left 1, up 1. 0, 0, right at that origin. 1, 1, right 1, up 1. 2, 4, right 2, up 4. And 3, 9, right 3, up 9. I connect them, making my U shape with my arrows on the end. I should also label because I'm going to have more than one on the same graph. So this blue one is f of x equals x squared. Now I'm going to graph my red one, and then we'll answer this question right here. Now negative 3, 18, when I go to graph that, 18 is way off the graph, so I don't need to actually plot that. So then I'm going to go to negative 2, 8. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, left 1, up 2. 0, 0. Right here in the origin still. 1, 2, right 1, up 2. 2, 8, right 2, up 8. And then again, 3, 18 is going to be way off the graph, so I can't graph that. So again, I connect these. Still make sure you go down to the 0, 0, because that's the vertex, and then come right back up. Still add my arrows on the end, and label. G of x equals 2x squared. That was the red one. So now this second part of the do now says, how does the graph of g of x, which is my red one, compare to f of x, which is my blue one? So they want to know, well, how does the red compare to the blue? I started off with the blue, then graphed the red. It looks like the red is a little bit smaller, right? It's not as wide. So the blue one is wide, and then the red one is a little bit in. It's not as wide. So what I'm going to write as this answer is that g of x is more narrow than f of x. And that's because of this 2 up here, which we'll talk about in a few minutes. All right, looking at the second one, it says graph the functions on the same graph. Okay, so f of x equals x squared. So it's really like a y equals x squared. Well, I just had that up here, so I'm going to write the same exact table that I used in the first part in the do now. So I have -3, 9, -2, 4. If you didn't recognize that, that's okay. You would just go back in the calculator and get those values again. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And then I have h of x, which is 1/2 x squared. So you can do this a couple different ways. You can put in alpha y equals. You can just put your fraction in parentheses when you go to type it in, or you can change that 1/2 to a 0.5. Okay, I'm going to change it to a 0.5 for now. But you could do it either way. So I go y equals, clear out what you have, 0.5 x squared. Go to my table. Okay, I see my balance. I have a 4.5 at the top, 4.5 at the bottom. Then I have a 2, 2, 0.5, 0.5, and then the 0 in the middle. So I'm going to write that table down. -3, 4.5, -2, 2, -1.5, 0, 0, 1.5, 2, 2, and 3, 4.5. If you didn't do 0.5 in the calculator like I did, and you put 1/2, or if you used alpha y equals, you would just get these decimals in fraction form, which is okay also. So now when I go to graph them, -3, 4.5. I'm going to go left. Oh, let me graph the blue first. Sorry. -3, 9. So I'm going to go left 3, up 9. -2, 4. Left 2, up 4. -1, 1. Left 1, up 1. 0, 0. Right in the middle, that origin. 1, 1. Right 1, up 1. 2, 4, right 2, up 4, and 3, 9, right 3, up 9. Connect them. Add my arrows on the end and label f of x equals x squared. Now for my red one, -3, 4.5, left 3, up 4.5. So 1, 2, 3, 4, but then it has that 0.5, so that's right in the middle of 4 and 5. I have -2, 2, left 2, up 2. -1.5, left 1, and then up 0.5. 0, 0, right in the middle. 1.5, so then right 1, up 0.5, so it's between 1 and 2. 2, 2, right 2, up 2. And 3, 4.5, right 3, up 4.5. 1, 2, 3, 4, and a half, that 0.5. Now I connect them, add in my arrows, and label. H of x equals 1/2 x squared. All right, we got to answer the question now. How does the graph of h of x, which is our red, compare to f of x, which is our blue? So this one up here, we said it was more narrow, right? Now the red one is out wider than the blue one. So what we're going to say is h of x is wider than f of x. And also, if you look at the y values right here from the blue and the red, To get from a 9 to a 4.5, I would have to multiply by 1/2. So besides it getting wider, what's also happening is that these y values are being multiplied by this coefficient. So the 9 times 1/2 is 4.5. The 4 times 1/2 is 2. The 1 times 1/2 is 0.5, and so on for the rest of the values, okay? But what you need to know is that the h of x is wider because of this 1/2. And for the do now, it was more narrow because of this 2. So if we look at the next page, that's going to help us with our notes. So in today's lesson, we're going to have to determine whether the graphs are getting narrower or wider just based on the functions. So our first note says when a is bigger than 1 or greater than 1, so I'm going to highlight that, the function a times f of x makes the graph more, I'm going to put makes the graph more, and then what I want to put in that blank is narrow. So for example, we started out in our do now and our questions on the previous page with f of x equals x squared. Then the first one was g of x. It became 2x squared. So it went from a 1 here to a 2 here. So this 2 is bigger than 1. That's the a value. So right here, this is like saying y equals 2x squared. This 2 is bigger than 1, so the graph becomes more narrow. If the a value, that coefficient, is between 0 and 1, so for example, that 1/2 on the previous page, 0.5, so fraction and decimal, etc. Between 0 and 1, the function a times f of x makes the graph more wide. So on the previous page, we had h of x equals 1/2 x squared. Well, this 1/2 is a fraction that's between 0 and 1, so it became wider. This 2 was bigger than 1, it became narrower. So we're going to use those rules all throughout today's lesson. So let's look at example 1. The graph of y equals x squared is shown to the right. Which of the following graphs y equals 2x squared? So I started out with y equals x squared, and then it became y equals 2x squared. Well, this 2 is bigger than 1. So if I look back up at my notes, if the a value is bigger than 1, that coefficient is bigger than 1, then my graph is going to become more narrow. So I'm going to write that here. Well, bigger than 1, it's becoming narrower. Well, this was my original right here. So which one of those graphs shows that it's more narrow? Well, this one definitely looks wider, so I'm going to get rid of choice A. If I look at C and I compare it to here, it's flipped upside down. I don't have any negatives, so it shouldn't be flipped upside down. I'm going to get rid of C. B, if you look at it and compare it to here, this started at the origin, the vertex. Well, this vertex is shifted over. But I don't have anything that tells me that I'm shifting over, because then I would have to have a plus or a minus. So it can't be B. So the only choice left is D. The only choice left is D. And if you look at the pictures, that is the one that is becoming more narrow. I said to explain your choice here. So what we need to write is that the a value is multiplied by 2. All right, that's where this 2 came from. It started out as a 1, it became a 2. So the a value is multiplied by 2, which is bigger than 1. So the graph of y equals 2x squared is narrower than y equals x squared. Okay, so multiplied by 2, which is bigger than 1, so the graph is narrower than the original. Example 2. The graph of the equation y equals ax squared is shown below. So this is y equals ax squared. We don't know what the a value is. They're just telling you that it's y equals ax squared. They graphed it for us. They want to know if a is multiplied by 1/2. Just highlight that. So if a is multiplied by 1/2, will the graph be wider or narrower? And explain your choice. Well, this 1/2, if you look back at our notes, is between 0 and 1. And when the a value is between 0 and 1, that makes the graph more wide. So what we're going to do is restate the question. The graph will be, so now we chose wider because a is multiplied by 1/2, which is between 0 and 1. Keep going back to these notes to help us with our explanations. All right, next page. Okay, multiple choice. It says, which statement best describes the change in the graph f of x equals x squared when the leading coefficient is multiplied by 4? So I'm starting out with this f of x equals x squared. And then it's telling me that the leading coefficient, so let's highlight that because those are definitely some vocab words. Leading coefficient, which is the number in front of the variable, is multiplied by 4. So my new equation, let's say, is going to be y equals, well, they're saying the leading coefficient. Well, the leading coefficient up here is a 1. They're saying that's going to be multiplied by 4. Well, 1 times 4 is 4. And then I bring down the x squared. So it went from a 1x squared to a 4x squared. Now let's look at our choices. The parabola will become wider. Will the parabola become narrower? The parabola will shift up 4 units, or the parabola will shift right 4 units. Well, up and right, or up and down, or right and left, I need to have a plus and a minus somewhere in my function, right? So let's get rid of 3 and 4. It's either going to be wider or narrower because I'm multiplying. Okay, well, this 4, I know, is bigger than 1. And from my notes on the previous page, if it's bigger than 1, then it is going to be narrower. So it has to be choice 2. Looking at example 4. How does the graph f of x equals 3 times x minus 1 squared plus 7 compare to the graph of g of x equals x squared? So what I'm going to do is I'm going to rewrite those over here. G of x equals x squared. That's what it started out as. And then it became f of x equals 3 times x minus 1 squared plus 7. There's quite a bit going on in this f of x function. All right, well, let's go with what we know. What we learned first, I should say. So this positive 7 all the way on the outside, not in the parentheses, hanging out here, I know that that plus 7 means up 7. Well, if I look at all my choices, it says the graph of f of x is wider than the graph of g of x, and it shifted left 1 and up 7. This one says narrower, it shifted right 1 and up 7. narrower, and it shifted 1 left and up 7. Wider, shifted right 1 and up 7. Well, all of these have an up 7. And in my equation up here, it shows up 7. Okay, so let's keep going. Inside the parentheses, I see an x minus 1. Well, you learned when we talked about horizontal shifts that when it's inside the parentheses, it's like the opposite way. So we normally think -1 means left, but it's really the opposite. So it's not left 1, but it's right 1. So up 7 and right 1. Well, let's get rid of what we can. This says shifted left 1, so it can't be that. This says shifted right 1, okay. This one says shifted left 1, can't be that. So we get rid of choice 3. And then this one says shifted right 1. So now, these are exactly the same over here. Shifted right 1 and up 7. Shifted right 1 and up 7. Now we got to decide, is it narrower or is it wider? Well, we just learned that in today's lesson. And the way we figure that out is by this 3 all the way in front, that leading number that's being multiplied. Well, that 3 is bigger than 1. Bigger than 1. So since it's bigger than 1, I know my graph is going to be narrower. So it has to be choice 2. Okay, let's look at example 5, A, B, C, and D. It says given f of x equals x squared. So that given is for all 4. So what I'm going to do right now, just to set myself up, is I'm going to write that f of x equals x squared on all 4, A, B, C, and D, because that's the original function that we're dealing with. Okay, so part A, it says if g of x equals 3 times f of x, how is the graph of f of x transformed to form the graph of g of x? Well, I started out with f of x is x squared. So now if I write g of x equals, well now it has a 3, times f of x. Well, that f of x is x squared. It shows me right here. So it's now becoming 3x squared. So started out as x squared, or 1x squared, it became 3x squared. Well, this 3 being multiplied is bigger than 1. And if it's bigger than 1, that means that the graph is going to become narrower. Let's look at the next one. If h of x equals 1/4 f of x, how is the graph f of x transformed to form the graph of h of x? Started out as f of x equals x squared. I need to now write h of x equals 1/4 times f of x. Well, f of x is x squared, so I'm just plugging in. So this 1/4 is the number that's being multiplied. It's that coefficient that's being multiplied, that a value. Well, 1/4 I know is between 0 and 1. And if it's between 0 and 1, I know it becomes, the graph becomes wider. So what I could say is h of x is wider than f of x. It's another way that you can describe it. If j of x is 0.5 f of x, how is the graph of f of x transformed to form the graph of f of x? I'm sorry, of j of x transformed to form the graph of f of x. Well, j of x is 0.5 times f of x is x squared. This 0.5, that's like a half. It's between 0 and 1. So I know my graph is going to become wider. And then this last one, if k of x equals 5 times f of x, how is the graph of f of x transformed to form the graph of f of x? So I have f of x is x squared. K of x equals 5 times f of x. So it's 5 times x squared. This 5 is being multiplied, and that 5 is bigger than 1. Because it's bigger than 1, my graph is going to become narrower. Now you can always check in the calculator to help you with these. Okay, let's say you maybe forgot the rule to determine whether it becomes narrower or wider. So I'm just going to go back to this first one for a second for an example. My original equation was y equals x squared. So let's just take a look at what that looks like. Okay, it looks like my original parabola, right? Now let's type in g of x. So I'm going to keep that equation right here. I'm going to go down to y2. And we're going to type in 3x squared. Okay, so now watch what happens. It's going to graph both. It's going to graph them in order. So the x squared is going to be graphed first, then the 3 times x squared. So if I hit graph, you'll see the first one was here. I'll do that again. First one is here. The red one is on the inside. And that makes sense because we said it became narrower. Okay, so you can always check with all of those. Okay, you would just plug in both equations and determine if it got wider or narrower. Okay, this last page is what you're going to try on your own. For the closure, they want to know whether the graph will become wider or narrower. Again, you're going to use these numbers in front, those coefficients, to help you. This one, it says it's multiple choice. Which statement best describes the change in the graph when the leading coefficient is multiplied by 1/5? And then this one is also multiple choice with the graphs. They want to know the graph of y equals x squared is shown to the right. So that's over here. They want to know which of the graphs would be y equals half x squared. Okay. You guys are doing great. Keep up the hard work, and we'll see you on the next video.